Greetings, welcome to this new video about superposition theorem. Solve the problem number 13. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of three resistors labeled R1 through R3 as well as two independent sources. Additionally, we can observe the presence of a dependent source, especially a current-controlled current source. The question now is to use the superposition method to find Ix and Vx. Ix is the current through the resistor R2 and Vx is the voltage across the resistor R2. Let's move on to the solution. First, we begin by identifying each independent source in this circuit. This step provides a clear understanding of the sources that will be analyzed separately. In this circuit, we can observe two independent sources, one independent voltage source Vs and one independent current source Is. Next, we proceed to deactivate all but one independent source in the circuit. This involves replacing the inactive voltage source with a short circuit, which means a zero voltage, and the current source with an open circuit, which means a zero current. Now let's begin by activating the independent current source Is and deactivating the independent voltage source Vs, which will be replaced by a short circuit. In order to calculate I1 and V1, I'm going to use the Nodal Analysis method. But first, let's consider I2 is the current through the resistor R1, and I3 is the current through the resistor R3. By applying Kirchhoff's current law at node A, we can write Is is equal to I1 plus I2. And if we replace Is with its numerical value, we obtain 6 is equal to I1 plus I2. And now by applying Kirchhoff's current law at node B, we can write I3 is equal to I1 plus 4 I1. That means I3 is equal to 5 I1. And according to Ohm's law, I1 is equal to VA minus VB over R2, where VA and VB are respectively the voltage at node A and B. And the current I3 is equal to VB over R3, and the current I2 is equal to VA over R1. Now by substituting A and C in 1, we can write 6 is equal to VA minus VB over R2 plus VA over R1. And if we replace R1 and R2 with their numerical values, and we continue simplifying this equation, we obtain 5VA minus 4VB minus 240 is equal to 0. And now by substituting A and B in 2, we can write VB over R3 is equal to 5 times VA minus VB over R2. And if we replace R2 and R3 with their numerical values, and we continue simplifying this equation, we obtain 5VA minus 6VB is equal to 0. Now by performing 3 minus 4, we derive one equation in terms of VB. And from here we can calculate VB, which given by 240 over 2 is equal to 120 volt. And from equation 4, we can write VA is equal to 6 times VB over 5. And if we replace VB with its numerical value, we obtain VA is equal to 144 volt. And from equation A, we have I1 is equal to VA minus VB over R2. And if we replace VA, VB, and R2 with their numerical values, we obtain I1 is equal to 2.4 amps. And now, according to Ohm's law, the voltage V1 across the resistor R2 is equal to R2 times I1. And if we replace R2 and I1 with their numerical values, we obtain V1 is equal to 24 volt. Now, let's consider the independent voltage source Vs active and the independent current source Is inactive, which will be replaced by an open circuit. In order to calculate I2 and V2, I'm going to use the nodal analysis method. But first, let's consider I3 is the current through the resistor R3. By applying Kirchhoff's current law at node A, we can write 4I2 plus I2 is equal to I3. That means 5I2 minus I3 is equal to 0. And according to Ohm's law, I2 is equal to negative VA over R1 plus R2. VA is the voltage at node A. And the current I3 is equal to VA minus negative Vs over R3. Now, by substituting A, B in 1, we can write 5 times negative VA over R1 plus R2 minus VA plus Vs over R3 is equal to 0. By replacing the resistors and the voltage with their numerical values, and we continue simplifying this equation, we obtain negative 10 VA minus 150 is equal to 0. That means VA is equal to negative 150 over 10. We get negative 15 volt. And from equation A, we have I2 is equal to negative VA over R1 plus R2. And if we replace VA, R1 and R2 with their numerical values, we obtain I2 is equal to 0.3 amps. And now, according to Ohm's law, the voltage V2 across the resistor R2 is equal to R2 times I2. And if we replace R2 and I2 with their numerical values, we obtain V2 is equal to 3 volt. After completing the analysis for each independent source while treating the other as turned off, the next step is to combine the results algebraically. This process enables us to determine the overall circuit response. That means the current Ix through the resistor R2 is given by I1 plus I2. And if we replace I1 and I2 with their numerical values, we obtain Ix is equal to 2.7 amps. And the voltage Vx across the resistor R2 is equal to V1 plus V2. And if we replace V1 and V2 with their numerical values, we obtain Vx is equal to 27 volt. After completing the calculation, we conduct a simulation using a SPICE simulator in order to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in the SPICE simulator. We can see here this is the independent current source Is, the independent voltage source Vs, the dependent source, a current controlled current source, resistor R1, R2, R3. I connect here a voltmeter in order to measure the voltage Vx across the resistor R2, and here in order to measure the current Ix through the resistor R2. Let's move on to analysis. This analysis calculate nodal voltage. We can see here the voltage Vx is equal to 27 volt and the current Ix is equal to 2.7 amps. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves as validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another problem about superposition method. Take care and bye bye.